This is a quick video on section 3.4 related to quadratic functions and power functions. Okay, and we'll try to take an Excel kind of bent to this kind of question. So just recall quadratic functions, we'll call them QFs for shorthand, are of the form ax squared plus bx plus c. Okay, so for example, an example of one is y is equal to x squared plus 2x plus 1. Okay, so notice that if you create a table of values for this function, you choose x is equal to 1, maybe x is equal to 3, and x is equal to 4. Then you'll get 1 squared plus 2 times 1 plus 1, which would be 1 plus 2 plus 1, which is 4. And if you use 3, you'll get 3 squared plus 2 times 3 plus 1, which is 9 plus 6 plus 1 is 15 and 16. And if you use 4, that'd be 4 squared plus 2 times 4 plus 1. That would be 16 plus 8 plus 1 is 25. Okay? So you know, if you know the formula for the quadratic function, then you can find some data. Okay? That step's pretty straightforward. The question is, how do you go backwards? Right? Let's say, for example, that you know that when x is 1 and x is 3 and x is 4, and you know the y values are 4, 16, and 25, how could you find the quadratic function that goes through those points? Well, the Excel solution would be to highlight the data, insert a chart as a scatter plot, and there are your data points. You could right-click them, add a trend line, and instead of a trend line, you would add a polynomial of second degree, which is a quadratic function. A polynomial of order 2 is a quadratic function, and then you could display the equation on the chart. Okay? And there you go, that was the formula. X squared plus 2x plus 1, that's the formula that we started with. So it's good that Excel can find that formula that we knew. Okay, let's bring in another question, okay, that you may see in section 3.4. What if you're asked to not just find a quadratic function that fits data, but what if you needed to find a power function fit to data? Okay, a power function is of the form y is equal to some number a x to the power p. So an example here is something like y is equal to 2x to the 4th, or y could be, 1x to the 3rd, or y could be 2.2x to the 1.5. No reason that the coefficient here, a, and the power, p, they don't have to just be integers or whole numbers. They can be decimals, okay? So if instead of being asked to fit data with a polynomial or a quadratic function, you can, let's delete this trend line, you can have other choices from the data in Excel or whatever your favorite spreadsheet tool is. You can fit it with the power function. Okay, and you say okay. Now this was the best fit was a quadratic function that went through all the data. This power function is only of the form a x to some power p. So in it won't fit exactly, which is what we're seeing here. But you can, let's see, just format the trend line, display the equation on the chart, and there you go. So if you have to fit the same set of data, x, y, 1, 3, 4, 4, 16, 25, if you have to fit this with a power function, that the best power function which fits is going to be y is equal to 3.9674 multiplied by x to some power 1.3053. Okay, there's a power function fit. The best fit is the quadratic function which goes through all the data. Right? But if you have to use some other function as maybe asked in the section, then you can use a power function. Okay. Excel is not the only way you can find the quadratic fit. Let's talk about that now. So let's get rid of Excel because we won't need it anymore. Let's show that some of these problems you can do by hand. Okay, so let's see. Let's add a page below. Okay, and here's a problem from, here's a problem from the textbook. Okay, let's see if I can get this on the screen at the same time just to copy it down. The question here is to find a quadratic function that goes through, that fits the data 0, 1, 4, 57, -1, 7. Okay, let's see if we can do this problem by hand. Okay, and then we can check our answer in Excel if you wish. Okay, now we've been asked to fit this data with a quadratic function. So we know that the x and the y values are 0, 4, maybe we should put this in order, sorry. Let's put this as -1, 0, and 4. When x is -1, y is 7. When x is 0, y is 1. When x is 4, y is 57. And as a quadratic function, that's of the form y is equal to ax squared plus bx plus c. So your goal is to find a and b and c. If you can find all the a's, b's, and c's, then you can fill in the blanks essentially to get your answer. Okay. Now we have x, y values. So notice that what we have when x was 0, that's a nice value to start with. When x is 0, you were supposed to get equal to 1. So a times 0 was 0, b times 0 was 0, c didn't have an x on it, so it's just c. So that tells you that the y value, which was supposed to equal 1 here, when x was equal to 0, tells us that c is equal to 1. So you filled in one of your blanks. You know c, that c is equal to 1. So now you know that y is equal to ax squared plus bx plus 1. And now you probably need to use the other 2 points. You haven't used this one and you haven't used this one. You haven't used x is -1 yet, and y is 7. So why don't you put 7 for y, -1 for x, okay, and then put 57 for y and 4 for x. And maybe we'll get some equations that we can solve. -1 squared is 1, b minus 1 here plus 1. Okay. The other equation is 57 is equal to 16a plus 4b plus 1. Okay. So this leads us to a minus b has to equal 6. That's our first equation from here. And then the second equation is that 56 has to equal 16a plus 4b. Okay, so there's your second equation. If you know two equations and two unknowns, the unknowns were a and b, then you can solve this system of equations. So a will be 6 plus b. That's what the first equation says. I'm going to substitute that into the other one using the substitution method. If a is 6 plus b, okay, these are 6's and that's a b. Maybe I should do a capital B here just so we don't get all the 6's confused. Okay, 56 is equal to 16 times 6. Let's bring out our calculator to check out what that is. 16 times 6 is 96 plus 16b plus 4b. Okay, so we know that that would be 56 minus 96 is equal to 20b. 56 minus 96 divided by 20 is equal to b. Okay, so 56 minus 96 is negative 40. Negative 40 over 20 means that b is equal to negative 2. If b is negative 2, then a is equal to 6 plus negative 2. So a is equal to 4. And we can now say that our quadratic function that fit that data is y is equal to 4x squared minus 2x plus 1. Okay, that was the quadratic function that fit the data above. Okay, so let's use that. Let's check our answer in Excel. Okay, you can bring Excel back in here. Okay, let's see. We had x was 1. Sorry, when x was negative 1, it had a y value of 7. X value was 0, y was 1. When x is 4, y is 57. Okay, so there's our data. Let's right-click on it, add a trend line, and we're trying to fit that data with a polynomial of order 2. Okay, show the options to see what the equation is, and as promised, Excel got 4x squared minus 2x plus 1, and that's what we got. Okay, so that ends this video on using Excel to check your answer for finding the quadratic or power function fits to a given set of data.